Hello there, welcome back. My name is Paul, I'm of The Best Tech. In today's tutorial, we're going to be building this out, what you see on your screen essentially, the e-commerce UI kit. I've got the Figma design over here, we're going to be going through that in a bit. But first of all, I will try to answer some of the possible questions you might have. The first of which could be, who exactly is this course for? So this course is for you if you already are good with Flutter, because I'm not going to be going into Flutter beginner details or whatnot. It's going to be mostly focused on Riverpod and the back end essentially, and how to combine Riverpod with clean architecture. So for that reason, I'm not going to be going into the nitty-gritty details of how Flutter works behind the scenes, or whatever little details you might expect from me. So mostly you're going to be seeing more details from the back end. We're not going to be focusing a lot on testing this video. So we're trying to put this video out and have as much information as I can put in this tutorial series without making it too long, right? So for that reason, we're going to be cutting corners and a lot of explanations when it comes to things I would expect you to basically know a little bit about. So testing is one of those things. This tutorial is not going to be majorly focused on testing. It's going to be majorly focused on Riverpod as an interface adapter, and somehow as a state management. It actually uses the new Riverpod API because the older versions have been deprecated. You can read more on that on the Riverpod documentation site. But back to it. I digress. This is who the course is for. The course is for you if, again, you have some Flutter expertise. You don't have to be very good at Flutter, really, but you just understand what widgets are and all those things, because I'm not going to explain them. And you may or may not want to know a little bit of JavaScript, but even if you don't, it's nothing too complex, really. If you already know Dart, like I said, you should already know a little bit of Flutter. And if you know a little bit of Flutter, then you also probably know Dart. So if that actually comes to be the case, then JavaScript should not be too difficult for you to pick up, because that was how it works for me. I actually picked up JavaScript after I learned Dart, and it actually was very familiar. Right, so I will go ahead and show you some of the differences between JavaScript and Dart in the next video. But for now, this is all you need to know for this particular talk. So let's get on to looking at the differences between JavaScript and Dart in the next video. You can skip that if you're already a JavaScript guru. So you can pull up any code editor that you've got. For me, I'm actually going to be using Vim. So I'm going to show you some differences between JavaScript and Dart and what you should be expecting and how they actually look similar. I'm going to point out some similarities between them and what you should maybe know before you actually get into the course. So let me go ahead and create a new project. I'm going to call this maybe test.js. Right. So what should you know? What should you not know? So in Dart, we know that Dart is very strongly typed. So usually we have things like string name is equal to, and that takes my name. It could be Paul, as it is my actual name, Paul. Sometimes with that same scenario, or that same example, string name is equal to Paul. Right. When I come to in Dart, essentially in Dart, you can actually go, if I come all the way back, I could actually remove the string, a type of it, and just say final name, and the Dart compiler will automatically know that the type of it is a string because of its initial value. That works. Now, also, if that thing is a constant, for example, it's a string is an actual constant, an integer is a constant. So if the thing is a constant, you can go ahead and let's remove this final and use the const keyword, and that will essentially set it to constant. But that simply means that you cannot change it. You can't change the value of it when it's constant or when it's final, right? So also we have this keyword var in Dart, where you can actually use this when you don't want to explicitly declare the type of it, the type of the variable, because let's say it already has initial value, in this case Paul, which is a string, and the compiler knows it's a string automatically. But then we could have used final for that, or constant. But then if we wanted the value to be changeable without having to explicitly state the type of it, we can use var keyword, and with that we can actually go to the next line and edit the value of name and say that name will now be equal to the best tech. And that is it, essentially. Right, so you can see the differences. We have const, we have final, we have var, constant and final. Simply lock it up. You can't swap it out, change the constants or the value of it. Then we have a var keyword, which gives you the ability to change the content of a variable. Now in JavaScript, essentially the same thing. Right, in JavaScript we don't have a final keyword, that doesn't exist, right? But what we do have are the constant, the var, and the let keywords. The constant is what it says. It makes it a constant. You can't edit it. Now you don't declare types in JavaScript. We can do that in TypeScript, but then we're not using TypeScript, we're using JavaScript because this is a Nodejs Express application, APIs. But in that case, we have a const keyword for things like name. It's still the same syntax with Dart. You can use single or double quotes for, and you can close it with a semicolon, but that's not very necessary for compilation to take place. It will compile either ways. But if you add, say, a formatter for your JavaScript, it will actually add the semicolon at the end of it in most cases. Now the constant means the name actually can't change later on. So you can't go and say name will now be equal to the best tech. This simply doesn't work, right? So if you wanted to do that, you can use the let keyword, which usually is more scoped than the var keyword. So when you're in a scope, or say in the scope of say a function or a loop, essentially, for example, in Dart we have for final word in a list of words, which could be called words, and you can do something with it. In JavaScript, sorry, that was in Dart. I don't know what I said. Probably said Dart. But if I said JavaScript, I meant in Dart. That is Dart. Now for JavaScript, you can use the same syntax and go for, this time instead of final, you have to use either let. Remember, we don't have finals and we don't have type declarations. We only have constant, var, and let. In the case of a loop, or when you're in a function, you can use the let keyword to mark a variable. Right, so we could say for let word off instead of in, off words, right? Do something with them. Now you could go ahead and use the var, but like I said, var is more used, or more generally used when you're in a global scope or in a more open scope. I'm not a JavaScript expert, but this is what you need to know. This is essentially, right? These work if you mix them up and you've got a pretty good formatter or a linter, a JavaScript linter. It will warn you and tell you to use a let keyword and correct scope. So you don't have to really worry about knowing these things. Just remember, we only use const or var or let to declare variables and whatnot. What other difference could there be? Functions, right? So functions are quite pretty similar, but then remember, in JavaScript, it's not strongly typed language, so you don't have to declare the return type of your function. So void get name, and then it does whatever it wants to do. When you want it to be a future, you can mark it async, and then inside you can use the await keyword and do whatever you want to do, right? So, let me actually leave that in async. Put this, and we could go await, and we do a future, right? This is Dart. In JavaScript, it would look something like this. It would be function get name. Now the async goes to the back of the function, and then you can in here await, do a future. So you see, similar. Also in Dart, you actually can use a try catch on futures to catch any errors, any potential errors. In that case, you would have something like, sorry about that, try, and then in here you do some future thing like await, do a future, then in here you catch any errors and you do something with the error. This is Dart. This is also exactly the same in JavaScript. Essentially that try catch await, do a future, and you catch the error, and you do whatever you want to do with it. Essentially, this is also how you leave comments in JavaScript. Also the same. We also have a different style of declaring functions. So you could declare a function and save it to a variable. This is more, I see this more than I actually see using the function syntax. So in this case, if we had a function that wanted to call get name, it would be as such. So constant, remember we use constant, let, or var. But when you're declaring functions, you mostly want to use constant if the function, or if the implementation of the functions doesn't change. Right? So if later on you don't want to go ahead and say maybe get name or now be equal to a different function, no, then probably just use a constant keyword. And that would be constant get name will be equal to an async. In this case, because we've got async function, it's a async function. We use an anonymous callback. The same thing that we've got in Dart when you've got on pressed on taps. Right, those callbacks, we also have them here, and this is the more popular way, in my experience, or from what I've seen from JavaScript source code, the more popular way of declaring functions. Right, we mostly use these, and we can go ahead and try it. Do a function thingy, and we await, do a future, and we catch the error, and we do something with it. Right, so this is essentially all you need to know. Variables and functions. Difference is how they work. It's the same thing as Dart, only difference is syntax, just very tiny syntax shifts. Yeah, that is essentially it. The type system is the same. We've got strings, we've got integers, we've got doubles, float or whatever. We've got booleans, we've got lists, and these things mostly work the same. So this is essentially what I think you need to know from this course. Anything else that comes up along the way, I will explain them. No worries. I am going to save this. I'm not going to save it actually. Let me. Yeah, so that is it. Let's go ahead and take a look or a sneak peek at the UI that we're going to be building to. and how we extract our logic. Next up, we're looking at the user interface for eCommonly. What are we building? So essentially, when you're building an app for production, you're probably going to have a UI team standby building the UI for you, unless, I don't know, under what circumstances you'd have to build the UI yourself and also write the code yourself. But even if that's the case, the point is there usually is a user interface for you to go by in order to build your software or your mobile software. So this is the UI that we're going to be using. From the UI, when there's a UI, it means there's already a flow. There's already an application flow built around, because usually how this works in actual real life use cases or real life scenarios is you've got a product owner. The product owner describes exactly what they want. Let's say they say, I want an app. You've been hired by a school. The school's a product owner, and they say, I have an app. I want an app where teachers can track student attendance. So this is a very natural languagey explanation. Now, the product designer takes that explanation, creates a wireframe out of it, creates flow essentially out of it, then wireframes that flow and creates the user interface based on that flow. But the point is, there is a user flow, so they decide, alright, we're going to have authentication because it's this or that, but for this and that reason we need authentication. Now the authentication will actually go this way. We will probably be taking only emails and passwords. We don't need phone numbers because we're not going to be using them or for that other reason, but they know what they need to do. They know how the flow needs to work. Well, we take only email and password and we take them to sign in. After that, if they don't have accounts, we push them to sign up. We don't need forgot passwords because maybe the passwords will be automatically generated or whatever. Or we need biometrics because of the user experience. It could be whatever reason. Then they go into the actual main app flow and they have these features and they explain the flows of these features. So whenever you look at a UI design, there's usually a flow to it. There's already been a flow decided. Now all you need to do, if you didn't have the UI designer who made the UI there to explain it for you, it's your job to look at that flow and notice how that flow works. You can see the several features: signing and forgot password. You can see the flow. It goes from sign in to forgot password and gets a verification code, and they verify. Creating an account takes create an account, generate a form, takes their information, then goes over to take the number separately, and so forth, and we keep going and going. You can see the flows from them. So from this flow you can figure out the things you need. So what do you think we need from this flow? You can see for the sign in flow, or we can group this, both sign in, forgot password and sign up, into one flow called the authentication flow, where for the authentication we need sign in essentially, because this button will call the API and say sign in. And for sign-in, we'll probably need a sign-in endpoint and a sign-in function. And when we're making that request over there, we will probably need to make a get request, a post request, or whatever. You can decide that later, or follow convention. But then, in cases for authentication, we usually make post requests, even though we're getting the user data after sign-in. So we decide exactly what we're going to be doing, and after we decide that, we go ahead and write the code for it. And we also know that for this request we will have a body that takes the email and the password, so we're sending data to the server this time, and we will also expect the server to send us back a user data. We get that user data to populate our user and whatnot. We've also got the forgot password flow. When they hit that forgot password button, it will take their email, send it over to the server, and the server sends them a verification code to their email, and they should type it in here. And we also make another request to verify the OTP and so forth. So you can see we can find the endpoints that we need from just looking at the UI design, and we can even generate repositories for our clean architecture. from just looking at this. So this is what we've got. We've got it both in the dark and the light mode, and you can see the dark mode as well as the light mode. We will be building these two out. We will try to make it as seamless as possible. And what else have we got? The API architecture. So we're going to be using the MVC architecture on the API on the server side, and for checkout we're going to be using Stripe as our payment gateway. For the admin dashboard or the admin panel, we will be, for this tutorial, using Postman to handle the admin part of it, and also for endpoint testing for API tests. Then for the admin panel, for example, uploading products and the rest of them, uploading categories. What else have we got? Deleting reviews or completing orders. All of those will be fulfilling orders, rather, will be handled on the Postman. Now, if you want to purchase the actual full code, you get an admin panel actually built out with Flutter Desktop. So we've got an actual Flutter Desktop panel, but we're not going to be using that in this tutorial. You can find that when you do purchase the actual course. The next thing I would want us to do would be to familiarize ourselves with the tools that we're going to be using. The first one would be Nodejs. Our second would be Express, and the third would be MongoDB, and the fourth would be Postman. Now I'm going to go through each of them one after another. Let's start from Nodejs. What is Nodejs? Why Nodejs? What is this monstrosity? So as you can see, Nodejs is an open source cross-platform JavaScript runtime environment. If you're coming from a place, by the way, if you're already advanced in JavaScript and you don't need this lecture, you can go ahead and skip it. Now, why exactly do we need a runtime environment? If you're coming from a language like Dart, you notice that you can literally just write Dart, and that is it. You can compile Dart straight away. Even if you wrote a server in Dart, you can literally just compile it straight up without any need for an extra runtime environment. The reason for that is because a language like Dart already has its runtime environment built into the language. This helps us a lot and cuts off a lot of hard work that we'd have to do as developers in order to set up our development environment. So what exactly does a runtime environment do, and why do we need it? Like I already said, Dart already has its own runtime environment built into it. So whenever you write Dart code, you see the errors or the compile time errors right there and right there. Whereas in JavaScript, when you write it, you don't see those things. You don't see the compile time errors and all that right there. This is because JavaScript doesn't have any runtime environment built into it. Now, a runtime environment will give you access to a runtime engine, and that is simply what will take your code, interpret it, convert it into machine code, and your computer will understand it. So that way we don't have to just write low-level JavaScript and try to communicate with the computer. So it gives us access to things like the input-output. So we don't have to write raw machine code that will literally tell the machine to output something for input-output or to collect input, essentially. So if you've ever written some JavaScript, you've probably seen console.log and stuff like that. So this is a wrap around the actual low-level code that tells the computer how to output information. So this is what a runtime environment does for us. JavaScript doesn't come pre-installed with a runtime environment, so we need one to do that for us. Now that we have our runtime environment, or the chef in our kitchen that will take everything and put it together and compile it, right? Now we need the framework on which we're going to build the server. Just like every other thing, we could go ahead and just build our server very plain Node.js and JavaScript with Node.js runtime environment very plainly. We could totally do that, just as you can go ahead and try to build a mobile application with Dart, plainly, without any framework. However, if you decided to do that, you're going to end up having to write a bunch of code in order to get anything done. So Flutter is an open source framework, essentially, so you can literally click and see the source code of it. Now when you click on, say for example, the stateless widget, it takes you into the source code for the stateless widget, and you see that it extends something called, I think it's an element or something, and when you keep going down you see render objects and keep going down and down, so you get to the very base of it and you see it's raw Dart code. Now a framework essentially wraps around the same thing that the runtime environment would do for us, and compile, take our code, interpret it, convert it into machine code and all that. A framework brings it even closer to human language. It makes it even closer to what we can use, provides libraries and all that. That is, by the way, the framework that we're going to be using for this particular one will be Express.js. You can see it's a minimalist web framework for Nodejs. You can see how you can install that, but that's for later. How communication works in a full application is where we have, say for example, a mobile device or whatever device that your end user uses, or a website or whatever. It could be a mobile app, desktop app, website. But the point is, there is data collection. This is where you collect input events from the user, collect data, whatever you need. You collect that here or from here, and this sat in the middle of the room would be our web server. In this case, the server that we're about to write. Now, this server gets data or gets requests from the device or from the platform, say a website. Gets that request, gets sent to the server. The server processes whatever data needs to be processed before it hands it over to the database. Now the database is where the data will be stored. On the server, nothing is ever stored on the server. The server is simply the brain. So this can be your eyes. Your eyes captures information from the outside world, sends it over to the brain. The brain processes that information, and then it stores it in some compartment, in your memory and whatnot. So that is also how this works. And let's take a very, very common example, which would be authentication, login. You display a login form to your user. User enters the email and enters the password. You collect that information and send it up to the server. Or let's even use a sign up example, because now we're trying to store data. So because in a login you're essentially pulling data from the database, so let's start from a sign up where you're sending data over to the database. So you show a sign up form, collect email, phone number, password and whatnot. Take that information, send it over to the server. Server, before pushing that information and splitting them apart and saving them into individual parts in the database, it doesn't just pass them over to the database straight up, because the database doesn't know. It's dumb. It doesn't know how to sort that data. It doesn't know how to find issues with that data and bounce the request. So that is the job of the server. The server receives it, does all the checks if the data is appropriate, if it has, the password has a correct length, if it a correct email, if this is correct and that is correct. It basically does all of the checking. Then it sorts that data, arranges it into proper readable format for the database, then sends that data over to the database to be arranged. It literally fixes them in their proper port or in their proper cabinets on the database, shelves them. Now comes the login flow. So this time the server uploaded data to the database. Now with the login flow, you're trying to pour the user's data into the user's device. This is why we do a login. So the user enters their details. You take those details, send them to the server. The server checks the database if those details, if any documents exist or any rows or information exists with those details. If it finds any, it will pull them and send them back to the user. If it doesn't find any, it will throw an error over here. So now the user does not have any direct access to the storage. The user only has access to the server, and the server shields the database from any such interactions. So this is why when hackers usually hack things, you don't ever hear that hackers hacked a database. You usually hear that the server was attacked, right? Because this is where all of the processing gets done. On that note, we use MongoDB to store our data. There's a lot of database solutions out there, but for this particular cause, and because of conventionality, because generally people always mix up or combine Nodejs Express and MongoDB. This is one of the most common combinations, so we're just going with one of the most popular and well-tested formulas out there. So MongoDB will be our database, so we send data from our user's device or from the Flutter application down to our server, which has Node.js as the runtime and Express as a framework that helps us build our server. Then the server, which uses these two technologies, will process that request and then talk to the database, which is MongoDB, pulls data or sends data over to it, and then it will talk back to the Flutter application. Now, when we're building a server, you usually don't have access to a client application, right? You don't have access to a Flutter application at that point that's talking to the server to do the testings and all that. So in that case, what do you do then? We introduce things like these, like Postman. And as you can see, where is it? Right there. Yes, Postman is an API platform for building and using APIs. Postman simplifies each step of the API lifecycle and streamlines collaboration, blah blah blah. Essentially, what we're using this for testing our API. So as we build the server, we need to test and make sure that the request is being sent to the database and the database is storing it, and we also need to make sure that the server is not throwing unnecessary errors and all that, and to make sure that it's throwing errors when we need it to throw errors and return success when we need it to return success. Even check the data type of the success data, and in order to test all of that, we don't have to go ahead and build out a whole Flutter application just to get that tested. Right, because that will be very horrible, having to build out a Flutter application just to get your API tested and then come back and fix this and fix that. So in that case, we use something like Postman, which gives us access, as you can see, the image over here. This is a screenshot essentially of something they've done, and that is a GET request. So they're making a request to the server to https at api.notion.com/v1 databases, getting an ID, blah blah blah, and they essentially get the response from the server. The server gets it from the database and returns it here essentially. So this is what we're going to be using, so we can start installing them one by one. And for that, let's start with Postman. Installing Postman is as easy as ABC. You simply, give me a second, reset. Simply head over to postman.com. You can type in Postman on Google and it should take you to Postman. When you arrive at postman.com, you find this section. Download a desktop app for this or that or that. You can download them, or you could actually use Postman on the web. By simply signing in, you can simply start using it on the web. So if you don't want to, you could literally skip this step, and when we're using Postman, you can just simply log into Postman on the web and use do the same thing with us essentially. Just follow along but on the web. Now, for those of you who want to download it, you can either do the Windows download, which I'm not going to do because I'm not on Windows, or you could do Mac, which I'm also not going to do because I'm not on Mac, or you could do Linux, which I am on Linux, and it's essentially basically the same thing for all of them. You basically download the binaries for your particular platform. For me, Linux, I could download either this or that. Simply, I think it gives me a tar, and if you already use Linux, you probably already know how to install a tar. If you don't know, you can literally Google it. If you're on Mac, Now it literally still takes me to the Linux site when I try to download for Mac because it detects my platform. This is very beautiful programming down there. When I also click on Windows, it also brings me to Linux, automatically detecting my default platform. Now you could go ahead and do that and get Postman running. Now I'm going to open up my own Postman. Now that I've got my own Postman open, you can see what we've got here. Alright, if you want to persist your thingies, your data and your endpoints and your test collections and whatnot, you could go ahead and log in, sign up on the site, then log in with your account over here. So that way, when you also decide to open your Postman on a different computer, we don't have the Postman app installed. You simply go to their website, sign in, and you will also still see all of your endpoint and your requests, that test requests that you've made. So we're going to talk about this later when we're actually using it, how to create collections and all that. We're going to talk about that later when we start using it. So moving on, we're going to Nodejs. Now for Nodejs, it's also simple as ABC. Go to nodejs.org and find your version. Now there's the version 20 currently. It's January the 30th. What we have version 20 is the latest, and it's 20.11 actually, and we have 21.6.1. Now the stable version is this, as you can see, recommended for most users, and this is the current release but still not stable. Now you could go ahead and choose either of them, but for me, I love my sanity, so I'm going to go for LTS. Now when you click on that, it downloads for your particular platform, and it also has information on how you can go ahead and do whatever you want to do for your platform, install it. For me, it's giving me a tarball, and I'm not going to install the tar because I already have Node.js installed. Now if you want more information on how to install Node.js, you can check out the written tutorial where we've gone into details on these things. So I'm not going to waste much time on them in the video because there's free information on Google as well. And if you also run into issues, you can ask in the community, or you can literally ask Google. ChatGPT actually, yeah, ChatGPT's got quite good lately. Next up is Express. Express.js, we do not manually install it. So as you can see, there's a little command, npm install express and save. Now I'm going to show you how to do that after I show you about MongoDB. So you essentially, npm is Node Package Manager, and we're installing Node over here. So we install Express using the Node.js package manager, which is essentially a package manager for all of its libraries. npm is just like pub.dev. So also when you're adding a package to Flutter, you use flutter pub add, the command that you use to add a package, flutter pub add the name of the package. So flutter pub add, and you write the name of the package. Flutter pub add this or that, and that is it. So moving on, we've got MongoDB. Now you can go ahead and either sign up with your GitHub or connect your GitHub or Google, or sign in with an email address. Anything you want to do, doesn't matter, go ahead and do it. So then I'm going to log in with my already existing account. After signing up and signing in, you get thrown into your MongoDB dashboard. This is where you manage your databases. You can create a lot of projects for free totally. It's just like Firebase. If you have any experience with Firebase, MongoDB should not scare you because it's the same thing. The document-based database, no SQL. So they both use documents. You store collections, and in collections you have documents, and each document has a unique ID generated for it. So it's essentially the same thing. You come over here, you click on, you can see all of your projects on your dashboard. I'm going to create a new project, and you essentially give it a name. Like I said, Firebase. Don't know Firebase, don't worry, just follow along. It's going to be alright. Take care of you. Project name, let's give that the best set. econ. Now, add members or set permissions. I don't have any members to add because I'm the sole proprietor of this project. So I'm simply going to click on create project. Wait for that to load. Project created. Now we have to create a deployment. As you can see, it's pretty straightforward. So after creating that, this is literally the next step that you need to do, and it's right there on your project dashboard. So you click on that create a deployment, and now you provision yourself a little cluster. We will go for the free version. And these things are just things you have to do over and over. Every time that you create a database, you choose a cluster, or it's going to put your cloud environment and whatnot. After that, you can choose your provider. I'm just going to go with the default to be AWS. These things you don't have to know what they mean because we're not here to learn MongoDB. We're just here to use their database service. And I'm going to leave the name as close to 0 by default. There's no point changing those. We click create. You can also go ahead and choose I'll deploy my database later if you want to do that later. But for now, we're just going to create it right away because I have to show you the steps. Nice. So now we have the cluster provisioned. Oh, it's still provisioning, so yeah, let's wait for that to complete. While we wait, we can come back here. We can just continue receive. Over here, you can go ahead and choose username and password. By default, already selected. As you can see over here, we've got a message. We auto-generated a username and password for your first database user. So they auto-generated a username and password, and you're going to need these. You're going to need your password, so copy that password and save it somewhere. You can go ahead and click auto generate if you don't like it, and it will generate again. So now they also know that we need this later, so they put the copy button over here and you can click copy, and I'm going to open a text editor and paste it or save it there. So that will be text editor, boom. Closing this up, opening a new one, pasting that. So that's my password. I'm going to create that user, and now we have to choose where we'd like to connect, either the local environment or the cloud environment. What do they mean? Now, the local environment, you can go ahead and add your local IP address of your computer, of your machine, and that will essentially let you connect from that machine every time. But when you use a cloud environment, it lets you set an IP, and usually people do this and set the IP to 0.0.0. In networking, it simply means global access. Anyone can access it from anywhere if they've got the IP address of your machine. So when you set cloud environment to that, the boring details, I know, but bear with me. You can also Google that later. I'm not going to go into the details of networking, but essentially the cloud environment it gives you all free access. So someone can actually access your database from somewhere by just having your database MongoDB URL for that particular database, if you catch my drift. But moving on, I'm going to use a local environment because personally I think that will give me more opportunities to teach you about the errors or the things that we can encounter with local environments. So I'm going to choose the IP address, which is already done. Added my current IP address, which I'm going to blur out in this video. Remind to future self, blur out the IP address. So I'm blurring out the IP address, but it's already added my IP address, and then you can click finish and close. Now I'm going to deselect the hide quick start guide because I actually don't always remember that, so I need them to guide me like a baby. I'm going to click on them, go to overview. That should take me to my overview page. There we are. We've got our database deployment, and that is it. Now, whenever you want to connect to your database, you can click on connect right here. I'm not going to do that at the moment. I'm going to wait till later when we actually need the database. So moving on, let's go into installing and using our Nodejs, setting up the entire server environment. The very next thing that we need to do would be to start creating or to start setting up the server environment. And to do that, we need to create a project on our local machines. The same thing you do for a Flutter project. Creating a Flutter project, this time we rather do it manually. Creating a Flutter project is quite easy because you have templates that get automatically generated for you. This time we have to create the folder ourselves, generate all the files, not generation essentially, but create the files ourselves or trigger the generators ourselves manually. Now, one way you could do this would be to open your files and create a folder in a proper directory, but I'm actually not going to do that. I'm actually opening my terminal, but you can go ahead and do that. I'm going to go into VS Code project if I have one, which I do, and I'm going to make directory. Now, after you do that, enter. I'm going to hit enter. Essentially created it. I'm going to go into my DBestech ecomly server, and I'm going to run a command in it. Now, if you have created this manually, this folder manually with your files, all I need you to do is to open that folder in VS Code. Now, I could go ahead and open up VS Code. This opens up VS Code for me, and you can go to open folder and then navigate your way. It opens up your file selector, and you can navigate your way through your home machine and find the folder and do what you want to do with it and open it. But I'm not going to do that. I'm actually just going to open that folder from here. So that is code dot. Should open it in VS Code, and there we go. We've got the DBestech ecomly server. Yes, I trust the authors. Me. Perfect. Nice. Don't mind VS Code. Silly little boy. Always asking silly questions. Right. So in here we've got a blank folder. Very, very blank. But we're gonna write history right there. So never mind and don't worry. Just follow me. Taking you to land. So you could actually go down here and find your terminal, which is click at the top, click new terminal, or use Control Shift and whatever little key combo that you've got here. But I'm going to use this. I always use this and click this, go to terminal, and we've got our little terminal. Now in here you could go ahead and run whatever commands that are centered around this project scope. But for me, I already also have it open over here in my main terminal, so I'm actually just going to run it here. So I actually don't like having a messy terminal in my IDE where I'm actually coding and seeing terminal code. Yeah, no, not me. I'm so sorry. So I'm going to have these separate. So I'm going to npm init. Remember what I told you before. npm simply means Node Package Manager. Node Package Manager. Now it's like pop.dev. When we actually want to install Flutter package, say for example provider, we could go Flutter pulb add provider, right? Now for npm, whenever we want to do something, we use npm install, right? Or you could go with the shorter form, which is npm I provider, npm install provider. It will install it into this directory. Now when I go ahead and run npm install the Express, for example, because we're going to be using the Express framework, now it goes ahead and it runs, but there's nothing here. You can still see it's still empty, right? Because that isn't how package installation works. So I'm going to clear this out. We're still in this folder, in this the best tech ecomly server folder, and we're simply going to run the npm init command, which means initialize a new Node.js project using Nodejs. So doing that and hitting enter, you feel like a hacker. So this utility will walk you through creating a package.json file. So now I'm just going to walk you through it quickly. The package name by default is going to be the best tech ecomly server. So if you wanted to change it, we'll type the new name here, but I'm going to leave it as that and hit enter. The version is version 1, obviously. Yes, the description, well, yeah. And the entry point, now you can leave this as a default, which is in, I don't know if you've noticed yet, but whatever you see in the brackets simply means when you don't type anything and you hit enter, that thing will be the default. So if it's index.js will be our entry point. Now, the entry point is just like in Dart, where we have the main.dart. The main.dart is the very first file that your Flutter final compiler will look for before it actually runs your Flutter code or your Dart code in Dart. Now, in JavaScript, you get to choose what. In Node.js, you get to choose what your entry point file will be. Now, I don't want to use index.js. I actually want to use app.js. You could go ahead and click here and add the app.js file. For me, I'm going to do that in the terminal. I know that I said that I don't like using the terminal over here, so I'm going to do that right here. Still in the same directory, I'm going to do touch app.js to create the app.js, and you can see that appear right there. I'm closing this down. Don't mind me, I'm just trying to show off my terminal skills. Yeah, so that's why I'm not using the GUI. Just like to show off. I'm going to change that to app.js and hit enter. Now the test command, skip that because we're not going to be testing the Git repository. You could go ahead and initiate or create a Git repository for this and then add it at the link right here. I'm actually going to do that right now so that you guys can get access to this code. So give me a bit. I'll be right back. Now I added my GitHub link. You won't? No, thank you. Author would be the best. Oh my days, can't spell. So thebesttech.com. Hit enter. License. I don't mind. You can use the ISC. And that is it. Is this okay? So we can go through and see the name is the best tech. Ecomly server version 1. Well, yeah. App.js. Blah, everything wrong. So I'm going to explain this later, but this is essentially what your package.json file will look like. The package.json is like your pubspec.yaml, right? So this is super easy, sweet. So is this okay? Yes, as a default, I'm just going to hit enter. Boom, package.json created. So you see, in Flutter, you automatically get these created for you, but over here we're doing the hard work ourselves with the help of this very beautiful command line tool that asks us for all of these, and we don't have to write them ourselves. Now you can see everything that we've done, all of the atrocities that we've committed, written out beautifully for us. And yes, oh my days, yes. So this is it. You can see over here we've got this little scripts section. Now you might ask, what is this? Because the rest of it we know. The Git repository, the author, license, bucks, URL, homepage, blah blah blah. But what exactly is scripts doing? You can see, oh, it actually has a definition. I actually never saw this my entire life. So it says that the scripts member is an object hash of scripts commands that are run at various times in the life cycle of your package. The key is the life cycle event. I'm going to hash all of this down for you. Right, so how this works is that whenever you actually want to run your server code, say any code that you've put in app.js, say for example we had console.log hello world. and we save this. Whenever you actually want to run this, you're going to have to go to your terminal. You could do that over here, but I'm actually going to do that here. Now, normally you know that in VS Code, in order to run this, we actually can go into, where is it, run, and then we run with either debugging or run without debugging. You can hit F5 on your keyboard, but that will actually run the file when I do that. Run without debugging, and I can choose Nodejs as my environment, and that will console log hello world, which is beautiful. But when we're building a server, right, because this is not just going to be us writing code, data structures are now algorithm code, where we just solve stuff with functions, and then we log stuff and all that, and then we don't actually build anything. No, this one we're building stuff. And why we build? We actually want a feature like hot reload. You know, hot reload in Flutter, where when anything changes, it automatically reloads for you, automatic. That is what we want. We don't want to have to automatically go and start debugging every time we write a new line of code, because this is what you're going to have to do. Every time you add a new functionality or you correct a bug, you're going to have to run this, because this runs once and it stops. It will run once and it stops. Console.log, and you do the next thing. So talk to server, talk to the database over here. You have to run that and have it running, and then you do the next one and have it running again. So that is it's very dangerous, because you don't want to have to do that. You want live updates where your server is up constantly. It's literally live throughout the life cycle of your development, throughout the life cycle of your usage of the app. So that way, whenever something changes, it restarts the server automatically. Hot reload feature. In order to do that, we need something called Nodemon. Nodemon is short. Wait, let me type that out. But I actually have to increase my font a little bit. Minimize this. Yes, so we have something called Nodemon. Use this a little bit. Perfect. I have something called Nodemon, which is short for Node Monitor, which is Node.js Monitor. For this, we simply type npm install, or you can go with the shorter version, which is node monitor, and you can see that appear right here. We go ahead and close down our package.json. Now, because we've added that, we need to add a script. What are scripts? Scripts are simply shorter ways of running long commands. Alright, it's like a type definition in Dart, where you define a long type in order to shorten it. So in this case, we have scripts. Let me zoom this out a little bit. In this script section, as you can see again, says that it's a member of the scripts member is an object hash of script commands that are run during the life cycle of your application. So if, say for example, you had a long command like npm install, you go ahead and add it here. So let's say every time that I wanted to install something or install Nodemon, I don't want to have to run the full command npm install Nodemon. Now I could go ahead and add the command over here as a value to the key of the script's name, essentially. Now the script's name is essentially the command that you put after. Let me show it to you, so don't talk too much without anything to show it for. So let's see, I added install, or let me call this, so that it doesn't look the same to you. Let me change the name of this and call it the best tech. Right, so now with this, I no longer have to run npm install Nodemon. I can simply say npm run, and I will give it the name of a script, in this case the best tech. So it will run whatever command I've passed into as the value of that key that I've given the run command. So if it's run the best tech, goes to my package.json, finds the script section, and then finds the key, right? The key that I've passed, and then finds the value to it, and sends that value to the terminal, and that gets run. So you can see when I run this, I've probably typed something wrong. Oh, I haven't saved it. Save and try that again. So this time you can see it's running this command, npm install nodemon. So this is the command that I've passed over here. It's running it. Now, in order to solve that little issue that I've just had, where you have to save this before you actually run it, you go to your settings and search for save. I think save automatically. This is it, auto save. It will, you can tick this off or on. I think, should I save it? No, I actually prefer to do that because it's super annoying, and I love when things are annoying. Makes it less boring to code. So I'm actually going to clean this, and the actual command that we actually want to add here would simply be the start command. Whenever you want to start your server, you actually have to run nodemon, and then you type in your entry point, in this case app.js. So we add that command over here, and then we simply use the start command. So whenever, let me save this, so whenever I actually do npm run start and hit enter, you see hello world, and it just waits. It waits on me. I'm going to append this service right here so you can see properly. Closing this down, and you can see hello world is over there. Now whenever I go in here and I change the hello world to hello world and I save it, Control S, you can see hot reload working immediately. I can actually go ahead and add a new command over here, console.log my parents, oh my bad, are not home, so I'll misbehave. Oh my bad. I'm just going to use a double quote. My parents and the moment I save this, it prints both. You can see hot reload in action. So that is the beauty of scripts, shorter commands that we don't have to run over and over. Now I'm going to shut this down by hitting Control C, clearing the terminal. And now if you're on Windows, if you want to do that clear thing, it's CLS. You don't already know that CLS command will work on Windows, but on Mac OS and Linux, literally clear. So that is it. Nodemon installed. We can do hot reload and start up a server. And we wrote our very first lick of code, which is the hello world, which is everyone's first code. And that is our understanding for setting up our environment. The environment is essentially set up now. So that is essentially all you need to know for server basic setup. Now we move into starting installing our framework and actually kickstarting the server, getting the engines running. So right now we've built a car, but then we need to turn the keys and get the engines pumping. So let's go ahead and do that. Now the last time we actually started the server with npm run start because we'd already added it. Now because this is so common that you have to start your server with commands like that. You actually don't have to add the run. So you don't have to npm run because you always do it all the time. So the script will still recognize commands like start with just npm start without a run, because these are very, very common commands. So you could totally abuse that. Oh, sorry. Clear on that. Clear. Right. So that is just to get that out of the way, because I forgot to talk about that the last time. Now, like I already said, Nodejs will be the runtime environment. Then we've got express.js, which will be the framework JavaScript is the basic language, JS language. So we got these three things to work together. So JS is basically like Dart when it comes to development. So I'm trying to draw a parallel between what we're using and what we are used to in Dart. Those who probably don't understand it yet. You can learn more in the written tutorial, though it's a lot more informative. But then this is Dart. This is the Dart runtime, which is pre-added to the Dart language. And then we have Flutter. So Express is just like Flutter. Express gives us the ability to do things without having to explicitly write lower level code. Like, it brings the level a lot higher. So we can literally do things like respond to or create routes. That is the routes that users will use without having to manually write them with JavaScript or in Nodejs, essentially. It gives us that wrapper, and it exposes some libraries to us. So say for example, when we use the Express, we have express.router, and with that router, there's a bunch of codes that's been written in there. And in there, there's just a bunch of code in that we would have written in order to just create our own router. And you're going to learn about routers soon, but for now, I just wanted to explain these. Now, kickstarting our server. Let me clean this up. Now, in order to start the server, remember the framework is Express. Now we have to initialize framework. So constant express. Remember what I told you in the start of it. This is equivalent to doing final express or final Flutter in a Dart environment is equal to if Flutter was like a package, and we could simply add the Flutter package, and that is it, and we import it. Let me do this better. Equivalent to import package for Flutter / Flutter.dart. If Flutter itself was an entire library, we had to import the Dart every time we wanted to write Flutter code. But this isn't the case. So in this case, Express is what it is. The library that we've literally added to package.json. We will add it and it will appear here. So in order to add that, we have to go ahead and do npm I express. That will simply add Express to our dependencies. So it's more or less like a library sitting in our app, in our web app. Not web app, server. But yeah, so after adding that, then we have to import it every time that we want to use any method from the Express framework. So in order to do that, this is how we do import in JavaScript. So we say constant and we initialize a variable to contain the framework Express, or to contain whatever we're importing. So it's also equivalent to doing this in Flutter. Import http package http slash, I think that's double slash, don't remember. http, is it? No, I think it's fine. http.dart as http. So what this does is it imports the library, but then it gives you front facing variable. You can actually use https dot get, https dot host, https dot client. So this is essentially what we're doing here as well. So in that case, we save it to a variable called Express. So you can literally use the variable or the object we've created to access it with its exposed properties. So that will be require Express. What this does essentially is importing Express. It imports it, and now you can see over here what it does: create an Express application, and you can see there's an Express function. The Express function is a top level function exported by the Express module. Now you can see we can invoke the actual Express imports that we've got here. So there's a call, the Express, that we can make. and we can actually do that right here. So because this in its own returns us an express object, and we could go ahead and invoke it, and it gives us it creates an import. Now after importing that and having a variable, we could go ahead and invoke that whatever this import exposes, and that will give us an object. I don't want to confuse you a lot, but so let's just go with conventions. So conventionally we separate that logic into its own app, else we will actually have to do this where we have express and we have to use the express on its own dot whatever we want to do with express. So I'm actually going to create an app. We call this the app, which will be equal to express, and we invoke it. Now this will give us an express object. Now with that object we could go ahead and do whatever we want to do. So you can see over here it's constant app is of type express. Now with the express object we can access all of the properties and methods of the express framework. Now one of such properties or such methods is the listen method, which is conventionally used for kickstarting the server. So this is more of one of those things that you just have to know, right? Or less boilerplate code, if you might. If you want to call it that, it could literally pass as boilerplate because we do it all the time. Whenever you want to start your server with Express, you have to do the same thing. So start server. Now in order to start the server, we use app.listen we use the listen method. What exactly is this doing? What is app.listen? So the app.listen is exactly what it sounds like. It's like listening to things in Flutter as well. In Flutter we have listeners. You attach listeners to controllers to services, and you essentially listen to changes. So this is also what we're trying to do. So with the listen method, it gives us access to a port. Hold on, I'm actually going to explain these. It gives us access to a host name, and finally gives us a callback. What to do when it's triggered? What to do when the listener is triggered? Right. So, but give you a second. This is a callback. Boom. So this is it. So whenever we want to start the server, what we're simply doing is adding a listener to a port at a host name, and then we tell it what to do once the connection has been established. So let's break it down. What is the port? Think of the port as say a virtual door at a specific address on your computer. So let's say your computer, the host name is the address that I'm talking about. So this is equivalent to an address, and this is equivalent to a door at the address. So if we lived at number 2345 Allen's driveway, and in that particular building, in that particular house, we have different doors. Now we're essentially saying go to this address, Mr. Hostnet 2354 Halland's driveway, and go to the door that I'm going to give you and listen to whatever happens within that door, or comes out or goes into that door. Now whenever, the moment you get there and you establish that connection, the moment you get there and you can start listening, I'm going to tell you what to do. So do this, whatever I've put in the callback. This is essentially what this entire thing was. We just add a very huge listener to certain port at a certain address, networking stuff, crazy stuff, very deep. You could go ahead and read more on that on Google. But this is what it is. Virtual door at an address, and then we tell it what to do the moment it's able to establish that connection. Now, the port number is simply the identifier of the door. So we have a lot of ports. A port can literally be anything. You can literally make up any port. Say 1234. It's a number, right? 1323 could be 32, 33. One of the most common ports for development would be 3000. We also have on port 8080. We also have port 80. We have port 443, and so forth. Now, when you hover over this, you can see port 80 and 443. These are more privileged ports. People use them a lot more often. 8080 as well. But then usually, what I've seen people do for Express or Nodejs development is use port 3000. Right, because it's not a privileged port, and the chances that some other servers on your computer is already using it pretty low, because 80 and 443 are more privileged, and another service, if you're maybe into networking or doing some network stuff, you probably might already be listening to 80 or 443 if you're already doing that. All right, but let's not hang around here. Now we give it an address. What address are we going to listen to? Now, the address could be anything. So in the case of development, we usually use localhost, which means the address is my computer. So we'll listen to every incoming and outgoing network operation on where the address is localhost, which means my computer. Now you can either use localhost to specify your computer, or you can use your computer's IP address. That would be 192.168.0.0 or whatever goes in there. Or you could go ahead when you go into production. Now that is for development. Let me leave that in for reference for you guys. Now when your app actually goes live to production, you can actually go ahead and replace it with anything else. It could be the IP address of the server where you've uploaded it, or it could be your domain name. So say for example, if you have http google.com, simply means that Google has deployed their server and it's in production, and they decided to use this part as their host name. And for their host name, they decided to use a domain name, and that domain name is google.com. Now this is I don't want to have to go into deeper details, but for those of you who have some networking experience or background, you will see that most times when we're pinging Google or we're pinging some website, you can actually replace this bit with that website server IP address, and you can actually find that website with its IP address. So even Google has an IP address. So when you want to find google.com, you can actually go ahead and in your web browser, let me open up my Chrome. Right, so I've got the search result, and you can see that Google's IP address is actually 8.8.8.8 or 8.8.4.4, and they've also got their IPv6 and blah blah networking, right? Confusing stuff. But then the point is, these are their IP addresses. Now we want to ping them. You can actually go ahead and use these addresses for ping them, and it will actually be pinging Google. So when I actually go ahead and type in let's see, you can see this is dns.google, Google's DNS, where you can actually enter a DNS and it will resolve it. So, but then the point is, you can visit any website if you know their IP address, the IP address of the server of where the server lives, and you can type that into your URL, and it will take you to that website. Essentially, you can use it to ping it. Now let's go back. So moving on, I can remove this bit. So the host name is essentially where we want it to live. Now when you leave this empty, it will default to localhost. Now it's a string, it's not an integer like this one. So it's actually a string, so it will default to localhost. Or you could go ahead, actually, so what localhost means is that only your machine, this local machine where I'm running this, can actually access this web server. So anyone or any phone or any Flutter client or any Flutter app that's running on a different device than my computer, so even if it's your actual phone that's connected to the same Wi-Fi network as you, so far as your host name lives on localhost, which means this computer, that phone cannot access your server. Right, so in order to have anyone from anywhere be able to access your web server, you do 0.0.0.0. 4 of them, as you can see. So this has become my host name. Now what this means is open my server up to the world. Now in order for it doesn't mean that anyone around the world could connect to your web server unless they actually have your IP address. So what this means is when someone wants to connect to your server, they actually need to go to http / the host name will be 0.0.0.0 at a port 3000. This is where your server is running at the moment, at port 3000. Then go to an endpoint that you've exposed in your server. So if you haven't exposed the endpoint, say login, they're not going to find anything. If you've exposed it, they're going to find whatever you've exposed in there. Now, when they're going to access your web server, they're going to have to replace this bit with your actual IP address. So let's say it's 192.168.0.0 at your port. Then they're going to find the web server that lives on this IP address, which is the IP address of your computer. So they're essentially saying, hey, take me to this computer, any computer in the world that has this IP address. Remember that IP addresses are quite unique within an environment. I mean, within a network, essentially, because when two people are connected to two different networks, they could both have the same IP address, 192.168.0.1. It could be that you're pointed 1 on this network and the next person on a different network is also pointed 1, but that doesn't mean anything, right? So, but then within the network, it's unique. So two people can't have the same IP address within the same network. Again, networking. Sorry for going too deep into that, but this is essentially what they'll have to do. Then it means that anyone can connect. They could also use the loopback service 127.0.0. So, still am going deeper. That is it, right? So anyone can connect when they have the correct IP address. So on that note, we could go ahead and leave it open because of our Flutter application. So that way we can easily connect to it from our Flutter application, because we're going to be running it on our physical phone. Now, even if you run it on your emulator, you also can't even connect if you're using localhost, because localhost means localhost for this machine. Localhost on when your emulator gets the URL and it contains localhost, it will try to find the localhost, and the localhost that it's going to get will be the localhost on your emulator. So whatever localhost means on your emulator, that is what it's going to get, which is different from the localhost of your computer. So it's going to get confusing. It's not going to work. So we usually use 0.0.0.0. And for the callback, we say whenever you're able to visit, whatever IP address that we have over there, then go ahead and the IP address, the host name at the port. Then go ahead and say something to me. What's the matter? Oh, sorry. Go ahead and say something to me. And usually what we say, so these are more conventional. You don't have to memorize them or anything. You can literally Google it up at any time. So what we usually do is say app.listen at the port, at the host name, and we go ahead and console.log. So to tell us, right, you could go ahead and use console.info to give you an information, but conventionally we say log, and then we say the server is running at, and we say HTTP because this is the protocol, because we're on local. It's not secure yet. It's basically on our HTTP server. So it's an HTTP for now. When you go ahead and upload it to an actual in production, when you're in production, you're probably gonna get HTTPS if your web server is using that sort of protocol. But on local, we're always using the HTTP protocol. You can't use HTTPS because it's local, right? So we go ahead and say it's running at, and then we tell the host name where it's running at, and this will be the host name and the port, right? So it's running here, http://hostname:/port, and that is it. Now in JavaScript, in order to interpolate a string, you have to use a backtick. as you can see, backticks. These work, and you use the $sign to with these. It's just like Dart, but then you know what I mean. Let's see. So it doesn't work that way. You only have to use the curly braces for the backticks. That gives you the ability to add these things over here, and this is why I have a problem with JavaScript, because look, it doesn't error this out. There's no hostname variable, but this lets me do this until I run the server, and then it dawns on me that there's no hostname. Let's go ahead and do that. Sorry, let me open up a new terminal. No, what am I clearing it for? Let's go ahead and cd into my VS project at the best tech ecomly server, and I'm going to npm start. Let's see. Still hello world. Wait, I actually never saved this, and you can see it's thrown an error. So this is my only problem with JavaScript, because it only shoots errors at runtime, so you never really detect them until you're running your server. So you can see it's saying that hostname is not defined. So let's go ahead and define the hostname. So the hostname will be equal to this, and we could go ahead and use that over here, and also use it over here, and we can also have a port saved. Constant port will be equal to, and we save the port. So we could go ahead and save this and see the server running properly now. So you can see the server is running at http :// 0.0.0.0 at the port 3000. So it's successfully listening. We can shut this down, clear it, and start it all over again. Start. And we can see that happening over there. Now you successfully launched the server. Now you could actually go ahead and try to visit this on your website, on your Chrome browser. Let me open that up. I clicked on it and it opened it in my browser. And you pull that browser window to the foreground so you can see it. So you can see cannot get. Why? Because we haven't created an endpoint that's / yet. So I could make this 127.0.0.1. It still calls to our server, but cannot get anything at all. So if we go ahead and pass in an address that doesn't exist, like let's see, 192.32. You can see it just spins forever. It's probably going to throw an error and say cannot visit that site or whatever. So that is it for kickstarting the server. Next up, we're going to learn how to save these things, not here but privately in an environment, in the environment variable. So we're going to learn how to use environment variables in our web server, store secrets, right? Because later on we're going to get API keys that we need. For example, we're also going to get a database string. We don't want to expose these things to whoever's reading our code. They're going to have to get their own database string and whatnot and use it when they're using our application. So I'm going to show you how to declare environment variables and also how to store secrets and how to use them over here. Usually when you're building your server, like I already said, you have secrets with, for example, your MongoDB connection string, which we're going to see later. But for now, I don't have anything to make a secret yet. This isn't really that important or something very risky, right? But why do we even need local security? Because this is the theme of it, local security. We have, like I already said, sensitive information like our API keys and the rest of them. Now, usually when we're working on apps or things like this in software development, we usually have to collaborate with teams of people, right? So usually when you have to collaborate with teams of people like that, there's the chance that you're going to commit your code to version control. like GitHub, GitLab, and whatnot. So in that case, you don't want to expose your personal stuff. You don't want to expose your API keys. Maybe you've paid for it and it's not for free. So you don't want to expose that. You want people to use theirs because they're going to put a toll on your bill and not theirs. So we usually want to hide those things. Now, in order to hide those things locally, we could create a file, right? We create a file locally on our local machine, and we simply read the information from that file over here. Now, when we're going to production, we actually do not, when we're adding our code base to version control, we don't want to commit. We don't want to upload. Whenever we're moving our code around, we don't want to upload those keys or those secrets along with it, so it doesn't leak and people don't get access to them. So in order to do that, there's been a convention made called env files, right? So it's env is simply short for environment files. So it's for your environment essentially. So in order to do those, you go ahead and you create a new file in the root of your project, and you call that a .env. As you can see, it's even got its own dedicated icon over here. Now with the .env, you go ahead and you save whatever you need to save. In my case, we have a host name and we have a port. Now when you're doing that, you do not write const. It's not JavaScript. This is universal. This is a universal thing. We even use it in Flutter all the time. If you've had to hide API keys and the rest of them in Flutter, you can also use this. You can use this in Python, any language at all. It's generally it's one of those things that are very general in the coding world. So we got a host name and a port saved over here. Now we don't use string thingies over here. You just go ahead and you save them. Usually we don't even have spaces. It would just be a host name equal to this, port equal to that. Now in order to get access to it over here, we have to read it. So we usually have to use IO operations, input output operations, and find the IO dot read, and then we read the env file, blah blah blah, which this isn't how to do it. I'm just saying IO could be input output dot read the file, and you get the data, extract the data from it. Now since this is something so universal in the programming world, like I said, it's very universal. We have libraries that help us read these files and extract data from them and save them in variables. And we can literally extract these things from them. And one of such libraries is the .env library. It's very popular. We've got one in Flutter as well. You could go to pub.dev, find the .env package in Flutter. So in order to install the .env in this case, we go ahead and we npm install .env. And wait for that to complete. Now after that complete, in whatever file or in your main entry point, whatever file is your entry point, you go ahead and in here you initialize. You go ahead and you require. Remember, I told you before that we actually save these things to variables, the imports to variables, just like as HTTP. But in the case of a .env, the .env library does not actually provide any object or instance to store. So instead, you just go ahead and you require it and use .env/config. Now you could do it this way, or you could just go ahead. This would work. Now after you do this, it actually goes ahead and loads and configures all of your environment variables, all the variables that you've got in here. It goes ahead and loads them, configures them, and then puts them into this process.env objects that is literally accessible from anywhere in your Node.js Express application. So I could literally go to any file, any of my JavaScript files, and do this and do process. As you can see, it's already there, giving me autocomplete.env, as you can see, and I can go ahead and access the variable. the way that I've written it. All caps, if it was in all caps, I have to use the same all caps. If it was in small letters, I also have to use small letters. So in my case, my port was all caps, so you could see port. My hostname was also all caps, I could also use hostname. Right, so the process.env, remember, you only have to do this once in this file. Now there's a different or more modern way of doing this. You can just go ahead and require.env, which will give us access to all the methods and everything inside the env library, and we could go ahead and use the .config, as you can see over here, .config, and we invoke the configuration. This is one modern way that you can see this. With this version of it, whenever it gives you the ability actually to pass in more options for the configuration. So say for example, it has this option called override. As you can see, overriding, you can pass that by default as false. So you can pass in more options to your configuration. This is the use of this. If you're not going to pass in any configs, you could go ahead and configure it right here. This is one difference that I personally know between the both of them. Now, I'm actually just going to process.env.hostname, since it was all caps in there, and process.env.port. Now, as you can see, this is getting repetitive. I'm simply going to capture this bit and save it in its own variable, and that would be process.env. env and env. Right, so let's save this and kickstart the server. npm start. So you can see there's an error, right? Invalid argument, blah blah blah. It's probably referring to my hostname. So let's go ahead and console.log on the information. Hostname is hostname. Let's do this and see what it prints. So you can see it's saying that hostname is Fedora. So it's actually going and fetching the actual hostname of my machine, of my computer. So hostname is probably a reserved name, right? It's probably a reserved name. So whenever you try to fetch hostname, the process.env will actually go ahead and try to. It's from Nodejs, as you can see, so it doesn't have anything to do with .env. So .env cannot override the processes, the process.env's reserved shell variables, because how this works is actually .env. When you do this, will actually fetch all of your envs and save them in the Node.js's environment. Or it loads them in there. It loads them in. So whenever you try to access them, you can actually get these things. Now, if there was already pre-existing keywords, you actually can't use them because it will cannot override Node.js. So it will fetch Node.js's version. So what we can do is change this to say host. Right, let's hope that works. So we can actually get this from host. Let's see if that, and go back to our web server, and we can see the server is actually successfully running, and we can also see the info that we've logged. Hostname is that, and save. Next up, we're going to talk about our routing. What is routing? Think of it like you're creating a new world, essentially. You're creating not a new world. Let's make it a new building. Let's make it a building. You're creating a new building. Now you've got your UI design, and you go through the design. This is how it usually works in real production and real use cases when you're working with a company and stuff like that. You already got the flow defined for you, right? So you usually have a user flow. So for example, you could come here, you can see that we've got authentication. For example, sign up. What does sign up do? As you can see in the user flow, the sign up gets the user's name, their email, and their password. And it tries to do what? It tries to save it to the database. So on the server, you're going to have to create the doorway. So you have the main gate, which is your thing over here, your hostname and your port. Whenever they want to do that, to do a sign up, they have to hit up, find your gate, and find the door to the particular house or building they're going to in that huge estate or colony. So in that case, after they find it, they're going to have to define or build more doors to specific areas in the house. So say, for example, they actually want to do a sign up. You're going to have to build a separate door for the sign up. Right. You could also combine routes, but that is, you can semantically group them, and that is up to you as a developer. What do you wish to group this functionality with other? But I digress. So you create a route, and you say the route is going to be go to my my host / localhost, so my protocol / localhost, or whatever host name you've got, on port so, and then / the thing. So / what. So if they're going to sign up, it could be / sign up. If they're going to log in, it could be / login. But usually I think I see more of register for sign up than login. So now you also have to decide what HTTP method they would be using. So we have the CRUD, create, read, update, delete, which I believe you've heard a lot of times, which is essentially what it is. These are database terms. You have to create data in the database. Then after that, you can read the data that you've created, and after that, you can update data that you've created, and after that, you could, if you wish to, delete the data that you've created. Now, there's more methods, but these are the main and the core methods that we use. The rest of them are fine-tuned versions of these, abstractions of these 4 main methods, right? So now you also have to, you also have HTTP methods that match these. Now the Express library gives us access to methods that let us carry out these operations. So when a user is going to create data, you usually use the Express, and you use the get, you use the gap rather, creating this post. So they're posting data to the database, post. We also have to read app.get to get data from the database. We're reading the data. So this is create data, read the data, then we have update the data, and we finally will have delete data. Now for post is for creating, get is for reading, updating will also be update, and no, sorry, what is wrong with the update is put.update. Sorry about that being silly this morning. And then finally we have the delete. Delete will delete the data. So these are the methods that the Express the Express framework exposes for us. So without Express, you will probably have to do the implementations of these things yourselves. But Express has helped us, and now we have these things, so we can manipulate data or put them in the database using these. Now, whenever you define a route using any of these methods, it means that the client or whoever is reading the data, is trying to carry out these operations on said route, need to know what method they're going to be calling. So if you define a route, say sign up, if register was defined with a post route or with a post method, and the Flutter client is trying to register, the Flutter client will also have to do a post, http.post, and then they go to the URL will be uri.pass and blah blah blah, right? So it has to match. So if the Flutter client is actually trying to get register, they're going to get the error cannot get. Of course, if you remember properly, we got that issue, we got that error when we tried to visit this website, because he cannot get to / because this by default ends with /, right? So this is by default /. If I actually tried to do / register, you can see it will tell me cannot get register, because there's nothing like a get request and app.get that has the /register thingy, right? So this would not work. So we have to use a post. But then on a website, whenever you actually put in a URL and you hit enter, what you're doing is a GET request, because this is what browsers are for. Browsers are only meant for getting data. So what a browser does is it displays data. So whenever you visit a URL, so let's say I went to figma.com/file/ the file ID, and then you can see the rest of it. So this is what it does. It goes over to Figma, the domain, goes over to the file, to /file, which means they've defined a route as such, a route called /file. And then in the file route, you go ahead and you give them the ID. So what they're doing is a GET request. So they're saying, get me the file that lives, go to the files, get me a file with that ID that has these operations or operators or whatnot. So it gets it, and then that on the server serves an HTML page and get rendered. In our case, we're building a REST API, not a website. So we're not going to be serving web pages. We're rather going to be serving JSON requests, JSON responses, because in Flutter we also get JSON and we decode them, JSON.decode. You can go ahead and serve XML if you want, but generally REST APIs usually use JSON, as we all know and love. So these are the methods that have been exposed. Now, that is what I call, let me leave that in for you lot when you want to reference. You can find this in the source code, which will be provided as part of the course. So I'm going to comment these out let me do that quickly. Boom, boom, boom. Pop. Nice. All right. So, wait, let me indent these. Nice. So you can find them that way. So moving on, we could go ahead and create our first route. So in order to do that, you can actually go ahead and do that right here, which I don't think not the server yet. I should leave that in. So you can go ahead and do that right here, right after you've declared the app, because we're going to do that with the app. So we can say app.get, and you can see we can define the /. Remember, it told us can't get /. Now with this, it gives you a callback that gives you access to the request that the user is being made. It carries all of the data, but the user is sending with a request. So if the user is actually sending a request and they want to give you, say for example, the sign up, they're going to make a post request and give you the user's name, email, password, and that you can get that from the request object over here. So we have request and we have the response, which we usually shorten to rec and res, which you're going to see more often than the full name. Response. And with that, we get this. Boom. Nice. Beautiful. Now from the request, you could get the request.body. This is why in Flutter, when you're making a request to the API, you usually do this http.post, and then you give the URI.pass, and you give the URL, and then you give a body, which will be a JSON encoded map that contains the data of the body. So it could be name, which will contain the username and so forth, and then you have maybe headers. You can also access headers from the request as well. So request has request.header, and you can see it has header and headers. We will see all of that later, but then this is what the request is used for. It's used for grabbing the data. You can also see all of the params, request.params. We also request.query params. Now, what is the difference between params and query params? Let's look at what these things mean. So now, in a URL, say for example, https/. Let us get a classic YouTube video. Now, when I head over here and I actually want to fetch any video at all, open this up, and you can see this. They're showing me at. Hold on, YouTube. Oh, sorry. You can see this URL. Let's go ahead and copy that and close this back up. Paste this here, and you can see it's got youtube.com/watch question mark this and that, right? So this is our domain name, and then when they visit that domain name, they're visiting this endpoint. So it will look something like this, like /watch. So if we haven't defined an app.get/watch, this wouldn't work. Now, after they visit the watch place, they go ahead and they pass us some extra data about what they actually want to do. And you can see it's got some sections. It's got question mark fee. Now, the question mark fee, let me leave that in. Question mark fee is 1 bit, and it's also got the AND. So these are ways of passing us data. Now, these things are called query parameters. So they're parameters that you pass with the query, that you make it to form part of a query, essentially. So they're not part of the main URL, because parts of URLs are attached with /this, /that. The moment you want to attach a query or build a query, you use this, which means you're giving more information about what you want with a GET request, because GET requests don't have bodies. So when you want to pass information like the name and this and that, you actually rather use query params, because we don't pass bodies. Remember, we don't pass bodies with GET requests. In Flutter, if you try to do atcp.get URI.pass and then you try to pass it a body, it does not have a body. You can't do that. You can rather give query params. Now, a query param simply give more information. So you can see it's giving a question mark. Question mark means I'm about to give you query params. This is how you start it. Now you give the first query param, in this case V, which means video for short. We're saying the video ID is equal to this. And then you could, when you want to add more query params, if you had name, email, password, you will concatenate them using the AND symbol. So it will be, I want the video that is equal to this, and the one that's from the channel, the best tech. So you can see how that works. And now we also have things. So these are called query params. Now we also have params, which are, these are path params, path parameters. Yes, so path parameters, which are simply params that have been passed directly with the URL. Remember what I said previously, just a few seconds ago, that these are not part of the URL, because when you talk about part of the URL, you're talking about things that have to do with /. So watch. Now, if YouTube wanted to take the video ID to find with the path parameters, they would have allowed us to do something like this. So watch / the video with this ID. So it will still work, because in their server, it would actually listen rather for request.params, which is the path parameters dot, and then you type in the name of what you're looking for. In this case, it would be the ID. So it could be something like video ID. Now, remember that when we were fetching for query parameters, which I actually haven't explained, you can actually wait request.query. In this case, it would be request.query dot, and then you should know what the user or the client is passing. So in this case, the client is passing the V. This will get us the video ID. So constant video ID will be equal to that dot V. And then finally, we also have the channel. So channel will be request.query dot, and it will be this. So now remember, if the user or the client goes ahead and passes query param key that doesn't match what you're using in here, you actually won't be able to grab it. So if they make a typo and maybe say AB channels, where what you're actually trying to grab is rather AB channel, your AB channel, your channel variable will be undefined, it will be null. So they also have to know exactly, this is why documentation is very important when you're writing APIs. You have to document everything possible, right? So now this is how to fetch queries. Then what if it was a path param? What if we had path parameters just like this? as you can see, it's part of a URL. It's not giving like this. We don't have this. In that case, if you wanted path parameters, you'll have to include it in the URL definition, in the endpoint definition. So in that case, it'll be /watch / and we take the ID, or you could call it video ID. But remember, whatever you've called it here will be what you use to fetch it. So constant video ID, or simply be request dot params dot video. As you can see, it's already given it to me, right? So dot video ID, whatever is it. So if this was ID, this should also be ID, right? So in that case, this is more descriptive, so the user doesn't have to, or the client doesn't necessarily have to go through the entire documentation to find every possible query param that they could pass. This way they know everything, but the only point with this is that you're going to have to add more // if you wanted to add channel, it will be channel name, which is in very conventional. So conventionally, we only use this for URL construction. So say for example, in this case where we have a watch, we're trying to watch. What are you trying to watch? You're trying to watch a video with this ID. So how these are usually used is with collections. So if say for example you want to fetch a particular user, you could go ahead and visit the endpoint users, which means the users collections at the user at this ID. If we had videos, it would be videos. So it could be /watch /videos and videos at this ID. So go to the videos collection, or go to the videos endpoint and find me the video with, in the videos collection, the video with this ID. Now this doesn't go and manipulate your database's collections. No, this is just a descriptive, a way to be descriptive, right? So it's giving more information to the client or whoever is using your API to say, all right, this says go to watch, go to videos, and get me the video at this particular ID. That is what it means. So in your video ID, you're just simply going to fetch it by that. That is the most popular use case of this style of fetching data, from the URL. Now for the body, you can also get it from the body. Rather, the body actually returns us an object, a JavaScript object, which you know from Flutter, from Dart, as a hash, as a map, essentially. So you could go ahead and access data in the body just like that, name and whatnot. So let's go ahead and delete these. So we could go ahead and return response. So whenever you do that, you get response dot. So this is me sending a response to whoever calls this endpoint. So /watch /videos and whatnot. Now we are going to respond with response dot JSON, which will convert it to a JSON. And we pass it in. And we can say video ID will be the ID request dot params dot ID. So the ID that they've passed, we're going to give it back to them, right? So this is it. Let's close this up and save it, and let's copy this and go to. So now that we're here, we're still seeing cannot get / because we have not defined /. But then we've defined something though, which I've copied, which is this /watch /videos /ID, and the ID, I'm actually going to give it a random ID, which is going to return back to us. Now you can see the video ID, it's returning it as a JSON, and this is a JSON, and this is a JSON parser extension I have installed on my Chrome. You could go ahead and install one of those, but this is what it's done. Turn me back the ID that I've given to it. So this is how this works. So if we go ahead and do an app.get /, so this way we actually have access to the /. Remember I said you can actually shorten this down to rec and res, and then when you want to return a response, you can do this res return. You want to use return keyword, return response dot JSON, because we're returning a JSON object. We don't want it to be a string. Or we can go ahead and try the string version. We can say welcome to my world, and with this you can even render HTML. So it could be and h1 and h1 goes. We could save this and we could take the user to /. Yes. So welcome to my world. Wait, this has to be rendered as a string and not JSON. So it'll send. In that case, use a send instead of JSON because we don't want to convert it to JSON. You can see welcome to my world. So you can see now we've learned a few things. We've learned JSON, how to return JSON REST APIs. But if you wanted to build, say, a web page, you'd use send because then you can send, as you can see, a buffer. You can send HTML. You can send a lot of stuff. And you can also see this thing here called status. So when there's an error and you actually want to return an error, we could go ahead and say dot send, or let's even make a JSON. Let's see the example and copy it so you can see, sorry, can't find that. Let's copy that, and you can see errors usually have status codes. Now this is where you give a status code. In your Flutter response, you can do response is equal to http dot post or get or whatever, and then after you can simply say response dot status code, and you can find that status code, and the status code will depend on the status code that you've passed over here. So it would be res dot status send. Now normally when you leave this out, it sends a 200. It means everything is okay. So when you want to give an explicit status, you have to use the status method. So let's go ahead and save this and see what we get. So when we try to visit this, there's can't find that. We go ahead and inspect this. We go to our console. You can see returned a 404. The server responded with a status of 404 not found. So when I go ahead and go back to my server and rather make this a 200 and save this, remember I told you that you don't have to explicitly set this to 200. The moment you leave it blank, then it just goes to 200. And we can see that it returned no errors or no 404s. We could also go ahead and try with a 500. And you can see it's a server error. 500 simply means server error. Let's redo that. You can see internal server error. That is a 500. So if you want to learn more about HTTP protocols, go ahead and simply Google that. HTTP response status codes and their meanings. So that way you also even need to know that because now you're building your own server and you're going to be serving your own status codes. So you need very much need to know what status code is required for what instance, which we're going to be doing a lot in this tutorial during the course of it. We're going to see status codes like 403, which is for forbidden, and so forth and so on. So no need to worry about that. I got you covered on that. But for now, let's go ahead and delete what we have. We no longer need these because we are actually going to create our own routes in different, because now we're going to have a lot of routes. So I'm going to show you how to create routes, or using the MVC architecture, abstract this into a different place and create routes in there and read them from here. And also we need to also know about middlewares and what they are, what they're used for. So let's clean this up. What else is there for a need for in this? So I'm actually going to leave that in here so you could get that for this portion of the code in the as part of the video. So you can see get that in the source code for this portion of the video of the tutorial. So let's move on to learn about middleware. Now up next we've got middlewares. Middlewares are essentially glorified listeners. I like to call them that. Glorified listeners because in Flutter we also have listeners where we could add a listener to, say, a controller. And that listener essentially carries a callback. Let me write some code. So we can have controller.add.autocompleting, add listener, and we pass that a callback. And in that callback, we write some code. We say maybe update a variable. So the variable will be equal to new value. So this will actually trigger only when there's a change to the controller, to whatever controller lives there. Now, when there's a change to it, it will trigger the callback, or it will carry out whatever function that we've put in here. This is also the same with middlewares. Middlewares are glorified listeners that sit between your main server and your client. So whenever your client sends any data or any request, anything they do, or even when requests are going out, you can put a middleware that will listen to all requests and those requests and do things to maybe the request, or do other things to some other code, or carry out certain actions before actually going on to the endpoints that the user or the client is trying to visit. So let's take this for example. We've got this endpoint called watch videos ID. Now, if a user or if a client is trying to visit this endpoint, we could actually add a listener that will catch. We use app.use to add middlewares. We use app.use, or we can add a listener that will simply catch whatever request, any request at all. It doesn't matter if it's coming particularly to this or to that, or to any request made to our server. We can catch it with this middleware, and then do something in there, right? Do something in there before we actually move on to the actual endpoint. So if the user tried to visit this, it will run this, then it will come to this. So let's go ahead and write some examples. So now this gives us the request, the response, and the next function. Now I'm going to explain what the next function means, or what it does. Yes. So the request, we already know what the request does. It gives us the request object from which we can access the body, the headers, and whatnot. The request params and query params, and we can also have the rest, which we can use to return a response. So now we can have the next, which does what it says. It goes on to the next function. Now you're not restricted to only one middleware. You can use multiple middlewares, app.use, and do the same thing, and next. And what next does is that it actually carries out whatever functionality you put in here, and then it moves on to the next middleware. So this is how it works. So the order of your middlewares matter. So if this middleware comes first in your app.js, or wherever you've put your middlewares, it will run this before that. It never misses. It never runs the one after it before that. So your declaration matters. If you actually need this to run before other one, maybe if you needed to authenticate users before moving on to the next middleware that maybe checks if users are admin, then you would have to put the authentication before the admin checker, so that the authentication runs first, and then if they're authenticated, you could go ahead and check if they're an admin. So in that case, the next function simply needs to be called. Else, if you don't call it, it will hang the user's request in the limbo of your middleware. Let me give you some examples so you don't get confused. So let me comment this out so it doesn't expect that. So let's see, I have this thing here where I actually want to console console.log, and by logging a request has been made to your server. Now when we save that and the user actually tries to visit the endpoint, let's find that. Right, so they try to visit the watch videos. You can see it just loads forever, because whatever request, you can see it gets printed to the console. A request has been made to your server. The reason why it's printed twice is because of when I click this at first, try to load this / with nothing else. It tried to get the first endpoint, which was this. And remember what I told you, this runs irrespective of what endpoints you're trying to visit. Now these are called global middleware. Right? I call them global middlewares because they run for every single request. It doesn't matter. They do not discriminate. Now you can see that it's hit this middleware, but nothing is happening. It's not moving on to the next function. So what happens is when you put next, it will actually check if there's another middleware, and if there's another middleware, it will run that middleware, and then when you call the next in that middleware will check if there's another middleware, and if there's no other middleware, it will go ahead and visit the endpoints that you're trying to visit. But this time we only have one middleware, so you can see it actually runs that middleware with a request has been made to your server, and then it gives me the actual endpoint. So as you can see, we can actually add a different middleware, and it will actually go ahead and run that one. So let's say console.log middleware 2. So you will see that middleware 1, let's actually not do the next first. So let's go ahead and save this. I'm actually going to close this, clear, and npm start. So when I actually visit this site, it loads forever, but you can see that in here, a request as a made to your server was called. But this one never gets called because there was no next. So when I actually comment that out and save it, it will actually come to middleware 2, but it will never move on to this. So let's see that in action as well. So let me retry. You will see that a request has been made to your server and middleware 2 was called, but then it never moves on here. So that means I also have to call next on middleware 2. So when I actually do this, you will see that it will work. So it goes to middleware 1, it goes to middleware 2, and then finally it gives me the JSON response. Now these are called global middleware. I call them global middlewares because there's a different type of middleware, which is the contextual middleware. There's also something that I call them because they're based on context, where you put them. You can put them within a route. So this is how you define a route: app.get, app.post, app.put, app.delete. But then after you put the URL, you can actually go ahead and put a middleware for that particular route. Let's say authorization, or I can't spell for the life of me. Authorization. Now this will be a function, so you don't use app.use for those types. You actually use a function, so you could save them to a function. Let's see, the function name will be authorization, like I've already declared over here. So you'll have to create that function, and then you give it a callback, request, response, and next. Now what I'm going to do in here is I'm actually going to just call next and say console, or let's go ahead and write out a full authentication call. So it would be constant is authenticated is authorized, authorization, authorized will be equal to true. So for the first bit, I'm actually going to say true. So I'm going to say if is authorized, then console.log user is authorized, and call next. Else rest.status will be 401. You can see we can also I don't have the rest, so there's a request response. We can also return a response from here, so it never actually hits the endpoint. It will throw an exception before it actually hits our endpoint. So dot send on authorized. Right, perfect. So now how this works is this will call the first middleware, the first global middleware, calls a second global middleware, and when it runs out of global middlewares, it will try to visit the endpoint. Now the endpoint will check if there's a middleware, then it runs the middleware, and then the middleware should also call next, which means move on to the next function, which is this function that we've passed to the route to handle the route. So let's save that, and oh, I've got an error. Authorization cannot access authorization before initialization. So sorry about that. I have to initialize that over here and save it. I'm going to close this down and declare it, and then npm start. Perfect. So I could go ahead and visit this, and it works. As you could see, user is authorized. We could go ahead and change this to false to say that the user is not authorized. And when I visit this and reload, you can see unauthorized. So this is how middlewares work. One advice that I'd actually love to give would be to always return. Always return. This has given me the most headache that I've had developing a REST API, because I always forget to return. Always return your next and your responses. So if you're returning a response in the middleware, return it with a return keyword. And if you're going to the next function, always use next. So that way it returns and it exits the entire middleware. So when I do this, it should still work and we don't have any hiccups. So that is essentially how middlewares work. Let me go over it again. We have a contextual middlewares and we also have the normal middlewares. That is the global middlewares that get executed for every single request. These ones are patterned to particular requests. So you can see that authorization has been added to only the watch videos and not to this. So when I actually try to visit this space, it will not print me the user is authorized or user is unauthorized. Let's see. Let's change this to true so that it prints it to console. So when I visit this, user is authorized, it's printed. And what if I actually try to visit / being the base endpoint? Oopsies. Invalid status code undefined. And what's the matter? So middleware 2 got printed. Invalid status code undefined. What's the matter? Where is it? It's here. Oh, sorry. I didn't put in any status. It has to be. Let's make it 404, not found. Yes. So, my bad. So sorry about that. So now when we try to load this, you say, sorry, can't find that, but it never prints the user is authorized because authorization middleware now, other middlewares execute. The first middleware executed, second global middleware executed, but then the actual contextual middleware it never executes for this endpoint because it's only patterned for that endpoint. If I go ahead and add it over here as well, authorization, and save it, then we could go ahead and visit this and see that it will say what user is authorized. So that is how middlewares work. Now, we usually will not, in the application that we're going to write, will not have to always write our own middlewares. We will use some already defined middlewares and that have been defined and put into libraries. We're going to use those to help us carry out functions before actually visiting certain endpoints. We have a few middlewares that we're going to be using for this particular course. Alright, so I'm right here and I'm removing these, removing this, removing that, this and that. So the middlewares that we're actually going to be using, but remember what I said in the last few minutes, is that the middlewares should be arranged the way you want them to execute, in the order you need them to execute. So a few middlewares that we're going to be using would be, I have these three main middlewares that I find very useful. One would be the body parser. Right, the second one would be Morgan, and the third one would be pause. Let's understand them. So body parser, it actually, when you get an HTTP request, the body of the HTTP request usually contains data, and this data could be in any format, like JSON. It could be, you see, we have this content type in the header, and the content type usually is application JSON, or it could be URL encoded and whatnot, or even binary data. Now, body parser will help us pop that data and make it available for us to use in our application. So whenever the user is sending any requests and it has any data, it will decode it. So you can think of it like JSON decode in Flutter essentially. It will decode it and it will give it back to us essentially. It will try to visit the endpoint that the user is trying to visit. So because implicitly the person who wrote it calls next. So the next will actually, after passing it, it will take us down then to the actual endpoint that they're trying to visit, and then the endpoint, when it tries to access the request.body, it will get the actual proper data type that we need for it. So for that reason, we're going to register it as a global middleware. Like I told you, globals. So all of these are going to be globals essentially. Now we have Morgan. Now what does Morgan do? Morgan is more of a logger, automatic logger. Like normally what I do would be I'd add an app.use and then I'll have to or try to print out the URL that the user is trying to visit. The user is trying to visit this URL and they're trying to use this method and they did it at this time and the response was this. So let me close this down. So Morgan actually logs all requests. So I think it also logs the response to the request. So it usually executes after or when you're sending a response up. So remember what I told you. Middlewares capture data both back and forth. So it logs the information back and forth. When you make a request, it makes a log. And then when a user makes a request, it makes a log. And when you send a response from the server, it also logs that response. So it does all of that in one line. So you usually see the log after the response has been sent. So that way it adds all of it in one line, the request plus the response that you've sent over. You could go ahead and pass in extra information to it, but I'm going to show you how to configure all of that later. Now for the cause is actually quite it's a bit more complicated. So this is what cause means. It means cross-origin resource sharing. So you can see over here, you can read more on Google or you can find more in a written tutorial, but I would try to explain it in detail over there. But essentially, cause defines a way for client web applications that are loaded in one domain to interact with resources in a different domain. So my web server will be hosted in a different domain and my client, like my Flutter client, will be hosted in a different domain. So now when they're interacting with each other, there will be, if for example my client is trying to interact with my API which is hosted on a different server, it's making a cross-origin request essentially. So it's not the same origin, they're not from the same server. So my client lives on a different server and my API lives on a different server, and there's a lot of intricacies that go back and forth with that. Just all you need to know, the TLDR of it is that cause will take care, the cause middleware, which has already been written for us, will take care of all of that for you. You don't have to worry about it, you don't have to know anything about how it works. All you have to do is use it. You could go ahead and read about it. You should know some things about how it works in case. Yeah, but that's essentially what it does. So let's go ahead and start adding these to our application, to our server, our API. Keep calling it an application, which it probably is, but so the first one would be sorry about that. The first one would be, let's do body parser first. So we'd npmi body parser. I think you can actually chain the installs. Let's see, Morgan and cause. Hopefully that works. Yeah, I think it will work. Nice. So let's see if they all got added, which they did. Perfect. So I'm going to close this down and close that down as well. And I'm going to start adding them to my application. So usually you actually want, like I already said, you want them to be before anything else because you want them to execute before your route executes. If you put the routes before the middlewares, then the routes will actually get executed or they will get called before the middleware gets called. And you don't want that because you usually use middlewares to bridge the communication. So you actually want it to be sitting between, so meaning above your server and before the client. So in that case, we have app.use body parser dot JSON, which will pass it into a JSON because we're using JSON. You can see it automatically imports it for me. And we also have app.use Morgan. And Morgan, you can pass it a config. and the config that we can pass it will be tiny. Let me show you the Morgan documentation. So this is the Morgan site. You can actually find all of your packages over here, npmjs.com. So the package that we're looking at will be Morgan, and you can see it's very popular. Weekly downloads, 4 million downloads. So you could see require Morgan, which you've already done, and a predefined format string. You go ahead and read all of these. You could go ahead and use this very simple configuration. You could go ahead and actually define your own custom configuration about how this configuration is essentially just how it prints the data. You can see that over here that we're telling it what to print. So it will print the tokens, .method, the URL, the status, the response, and so forth, right? So you could also use the combined and so forth. You could go ahead and read this, but we're just going to use this. It's pretty simple. So I'll go back to my Node application, and I'm using Morgan. Now for calls also has documentation on, let's see, calls npm. And we could see calls npm, and we could see how that also works, how we can configure it. So you don't have to know how the configurations work for these things, maybe memorize them. No, you don't have to do that, because you can literally just come here and see all of it, how it works. So you can see app.use calls, and we could go ahead and add that to our application. Now we could go ahead and also see that there's some options, extra options. Let me see. So you can see this is an origin. So the option, when you set that option over there, it only allows for functionality from that route. So you could go ahead and add those sort of options. Where is it? So we have app.use, first of all, the calls, right? And we invoke it. Then we use app.options to add an option, right? And the option that we're adding is for this, meaning all routes. So and then we add this. So this is also one of those things, boilerplates, that you just don't need to remember. You can just copy paste it all the time. So this is usually how we conventionally configure the calls. If I go into details of what these mean, it's going to be pretty long. But so what this is essentially doing is it handles the options request for all routes, right? Because we're using this asterisk sign symbol over here, which means all routes, like all routes. And sometimes your browser sends this thing called a pre-flight options request. Check if the request that you've made, like get or post, is safe to send. So when you do this, you're simply telling Express to respond to these pre-flight requests from your browser with the calls header. So whenever they send it from any route at all, use the appropriate calls header to allow or deny the actual request. So this is essentially what it means. Technical details, so boring, just you can copy paste it all the time. That's all I'm trying to say. So that are our 3 most important middlewares. Now let's go ahead and talk about the database. This is where the fun begins. So I'm actually going to remove these routes over here. Well, I'm actually going to leave those in until we're able to create, separate, or abstract the routes. So start the server, hostname, and these important. I believe they are. So I'm leaving them in there. And we also have to go ahead and import calls. So I don't know why I had imported calls. Come on, mate. No, you're not going to help. All right, I have to do everything by myself. So C ABC constant calls is equal to require calls. Let's save this and make sure that the server is running fine before we move on to databases, because I totally forgot about that. Claire, perfect. npm start. Nice. Yes. So let's go ahead and move on to the database.